Good day. So we're going to have the second part of probability of an event. So we're now going to have some counting techniques or simplifying counting the elements of the sample space. So counting techniques is an important part of combinatorics, the study of arrangement of objects, which is part of discrete mathematics. The methods used for counts of the numbers of outcomes in the sample space and various events for analyzing random experiments. This is used for more complicated problems and more difficult sample space or an event. The first counting technique is the multiplication rule. If an operation can be performed in n1 ways, and if for each of this a second operation can be performed in n2 ways, then the two operations can be performed in an n1 times n2 ways. Example: how many sample points are there in the sample space when a pair of dice is thrown once? So take note, we have a pair of dice. So first die, second die. So this would be die 1 and this is die 2. The first die has 6 possible outcomes while the second die has 6 possible outcomes. So all in all, there would be 6 times 6, which is 36 total possible outcomes. Let's have now generalized multiplication rule. If an operation can be performed in n1 ways, and if for each of this, a second operation can be performed in n2 ways, and for each of the first and to a third operation can be performed in n3 ways, and so forth, then the sequence of k operations can be performed in n1 times n2 times and so on and so forth up to n sub k ways. Example: Sam is going to assemble a computer by himself. He has the choice of ordering chips from two brands. So first, let's have the chips. So from the chips, we have two. And a hard drive from four. So let's have hard drive HD. We're going to have that from four. And a memory. The memory is to be chosen from three. And then accessory. For the accessory, we're going to have that from 5 local distributors. How many different ways can Sam order the parts? So it would be 2 times 4, 8 times 3, 24 times 5, which is 120 ways. In how many different ways can a test or a true or false test consisting of 9 questions can be answered? You might be thinking you are seeing true or false. That would be 2, and there would be 9, so that should be 2 times 9, which is 18. That is wrong. In answering a true or false test, for every item, you have true or false. For the second item, you have true or false. You do that for the rest of the exam, so 2, 3, 4, 5, 6, 7, 8, 9. So question 1, 2, 3, 4, 5, 6, 7, 8, 9. And every question can be answered by true or false. So two options for every item. So this would be 2 raised to 9. How many even 4-digit numbers can be formed from the digits 0, 1, 2, 5, 6, and 9 if each digit can only be used once? So first, let's have no restriction. We are talking about 4 digits. For the first digit, so we have the options 0, 1, 2, 5, 6, or 9. So that's a total of 1, 2, 3, 4, 5, 6. So that's a total of 6. However, we can't use 0 as the first digit, so we have 5. For the second digit, all of the digits are possible. Same is true with the third and the fourth. So this would be 6 times 6 is 36 times 6 is, so I think this is, let's have our calculator for this. Please use your calculator as well to verify whether what will be your answer. So this is 1080. Now, each digit can be used only once. So meaning, uh, if there would be no repetition of digits, that would be, for the first digit, you have 5 options. 0 cannot be used. For the second digit, you can't use 1, because if you have used the first digit already, so it would now be 5. So the first digit used cannot be used as a second digit. And then 4 times 3. So the first two digit cannot be used. So that would be 6 times 2, 6 minus 2. And then the first three digit used can no longer be used. So that's 3. So this is 5 times 5 is 25 times 4 is 100 times 3, 300. So there's a total of 300 numbers for no repetitions allowed. If we want to solve for the odd numbers, we start with the last digit. It should be 9, 5, or 1. So we have three options for the first digit. For the last digit. For the first digit, we can't use 0 and the first digit chosen. So that's 4. From the 6, we remove 0 and we remove the number chosen as the last digit. And then we have 4 and then 3. Why 4? So we have the first digit and the last digit. So that's 2. So 6 minus 2. And then for the third digit, we already have three numbers selected. So 6 minus 3 is 3. So this is 144. For the even numbers, that would be a total of 300, the total numbers minus the odd numbers. So what's left would be 156. So this is the even numbers. So let's have some formula-based computation. If you're going to arrange an element in a line, we're going to use the factorial. So if you're going to arrange A, B, and C, the possible arrangements are ABC, ACB, BAC, BCA, CAB, and CBA. This arrangement in a line, so take note, this is linear, is our factorial notation. Example, in how many ways can 5 different books be arranged in a shelf? So that would be 5 books. So the first book can be any of the 5. The second book would be any of the 4 remaining books. You have selected 4 books already, so for 5 books minus 2 would now be 3, 2, and 1. Applying a multiplication rule, so this is 5 factorial. You can evaluate this using your calculator, and you know that the answer is 120. If you need to arrange everything in a circle, the arrangement would be n minus 1 factorial. So in a circle, you fix 1 because it is rotating. So you fix one of the elements, that's why it would be n minus 1 factorial. Example, In how many ways can 5 different trees be planted in a circle? So there are 5. So this would be 5 minus 1 factorial. If we want to select the items that we will be arranging, so this would be a special permutation NPR. So that would be NPR, which is denoted by this symbol. So if we want to select first, select R from N, then arrange, we use permutation. In how many different ways can the top 5 students be awarded from the class of 20 students? So top 5. So we have the top 5 positions. Top 1, top 2, 3, 4, and 5. So the top 5 positions, top 5 slots. So for the first place, we have 20 options, any of the 20 students. For the second post, 19, 18, 17, and then 16. So this is the same as 20 permutation 5. So you can evaluate this using your calculator. Permutation of similar objects. If you will be having arrangements of similar objects wherein you can't distinguish one from the other, we will be having the permutation with repetition. For example, the word infinity. There are repetition of objects, or there's a repetition of items I and N. So for I, we have 3. For N, we have 2. And then F, T, and then Y. So that would be 1 each. So all in all, we have 5, 6, 7, 8. So I think there are 8 items. And if you're going to arrange infinity, there would be 8 factorial ways. But there is a repetition of I, so that would be 3 factorial ways. For N, 2 factorial ways. And the rest, 1. So this would be for the arrangements of the word infinity. In partitioning, if you want to partition N into subgroups of sizes N1, N2, and Nr, where N1 plus N2 plus N3 up to Nr is equal to N, the number of permutations would be N factorial over N1 factorial, N2 factorial, and so on. So as an example, if you want to divide 7 into a triple and 2 doubles, how many permutations can be formed? So that would be 7 factorial over 3 factorial, 2 factorial, and 2 factorial. That is dividing 7 into 1 triple and 2 doubles, double 1 and double 2. So you can evaluate this. Now, for combination, a combination is actually a partition of 2 cells. The one cell containing R objects selected from N, and the other cell containing the objects that are left. So that would be N minus R. The number of such combination is denoted by N combination R. Since the number of elements on the second cell must be N minus R. So, for example, how many poker hands of 5 cards? A poker hand is a card containing 5 cards. And a standard deck has 52 cards. So from 52, we select 5. Also, how many cards are there to select? 47 cards. So that is also 52 combination 47. Take note that they are the same because from 52, you're going to divide them into 47 and 5. So if you're going to evaluate that, they are just equal. So 52 combination 5 and 52 combination 47. These are some of our references.